Okay, so welcome everybody. So I can't see you guys. I can see only my screen. So we will be using Miro to run this complete session. So put some instruction here. So I think Anu will put the URL to this one. Everybody can go to the Miro board. And then so basically we have a packed agenda. So I will just provide an overview, and then Dario is giving a talk. And then there will be 4 lightning talks. And then we will have a group discussion, group activity. So that is about the interactive whiteboard session, where there are a couple of questions we have come up with, and then everybody will have an opportunity for each of the questions. You will get 3 minutes to answer that. And then we will come and discuss those answers. And then in the final, we will make have a quick discussion on where we go from here, kind of a thing. So I think the main motivation of setting up this BoF is to work on the semantic interoperability of the Flux data. This is in continuation of in the last year. I think it was P15 RDA. It was a Melbourne RDA. That was the first remote RDA. We ran a session on the interoperability in Jerry. So Jerry is the global ecosystem research infrastructure, and then how we can improve the interoperability between the infrastructure. So our focus is more on the infrastructure side, the research infrastructure side. And then the one on part of one of the discussion was that there was a bit of a consensus that the Flux can be like a low-hanging fruit to look at, because it's a well-coordinated community, and then they work very closely between the different continents who have the Flux research infrastructure. So that was one of the motivation to look at the Flux data and then see what are the interoperability states we can. So the aim of this BoF is to bring the research infrastructure who are working on publishing the Flux data to explore the semantic interoperability, and then discuss some of the opportunity and challenges and work on the future plan. Just to provide a bit of an overview, there will be a few talks on this. The Flux research infrastructure operates at the multiple continents, and then so predominantly eddy covariance flux measurements is used for to measure the energy exchange, carbon and water. And as I said, the community is well coordinated, and then so at the Fluxnet, thanks to the Fluxnet, there will be a massive sharing of information between the different towers and from a different region and the continent. So one of the things we want to explore is the semantic interoperability. If you look at the interoperability, in a short definition, is the ability for a system to exchange and use information. So it's a different level in the interoperability. So the syntactic interoperability. So basically, it is the definition of the structure and the format of the data exchange. And then there is a structural interoperability, which defines the schema of the exchange. And then there is a semantic interoperability. So this basically deals with the meaning of any artifacts exchange. So the main idea behind this, if we are exchanging any data, then the information, there should be a link to the meaning of those elements. So generally, it's done with the shared control vocabularies to enable this kind of semantic interoperability. So the main motivation for this is, if there is any exchange of information, there should be an unambiguous meaning, so that the one system clearly understand what the information is exchanged and the meaning of those information exchange. So again, there are a bit of a legal interoperability and everything, which was so that probably is not the scope of this conversation. So the scope of the conversation is about the whether we can manage the semantic interoperability at the research infrastructure level. So with that in mind, so I will hand over to Dario to give a bit of a presentation on some of the work Dario and his team are working on I will stop share, Dario, and then pass it on to you. So Dario, you can share your screen.
Yes. Okay.
So while Dario is sharing, so we request everybody to stop the switch off the microphone and then the video so that everything is clear.
Okay. So I now see only my screen, my slides. So if there are questions or if you don't listen to me anymore, or if you lost something, please just speak because I cannot see the chat or anything else. So what I try to do here with this short presentation is just to give an introduction of what we are talking about. In particular, because the Fluxnet community is a complex community that, however, not everybody are aware of what it is. And so I try to do this, also look into which are the data issues, challenges that are more relevant, let's say, for this conference. But before that, I need to give it's good to give for the non-expert people a little bit of flavor of what we are doing. So in this Fluxnet and Flux community, what we measure greenhouse gases exchange between a surface and the atmosphere. So, for example, how much photosynthesis is doing our forest, or how much respiration, or how much greenhouse gases are emitted from a city or from a lake or from a piece of ocean. And we measure this in an area that is about, let's say, 500 meters around the measurement point. And the measurement point is one of the one that you can see here in the top picture. So we have these two instruments together. It can be a short tower, it can be a tall tower, it can be a very tall tower. What is important to understand, just to understand the amount of data, is that we have a measurement of this exchange for each half hour, and these are measurements that are going continuously. So this is kind of the final product. In fact, the original data are much more, let's say, frequent. So we have a 10 Hz or 20 Hz measurements, so 20 measures per second. And what we get at the end is something that can be summarized by this fingerprint plot. So here you see there are different years on the x-axis, time of the day in the y-axis, and then you see the different colors. And so where it's going to the blue is the growing season. So that means that there is a uptake of CO2 by the ecosystem, and that's normal. So in winter, for example, there are no leaves, and so there is no uptake, and then it started the growing season, and you see that there is uptake, and you see that this is nighttime when it's red, so there is no uptake, there is no light, and so on. So the amount of data produced is quite large, it's quite complex, the technique, but in addition to the fluxes, we measure also a set of additional variables that are really important to interpret the fluxes. So, okay, the photosynthesis, but I need to know also how much was the light, which was the temperature, and also which type of ecosystem it is, how much was the biomass, and so on. So we have a multitude of variables that go from half hourly to once per year or once every 5 years that are really heterogeneous. And the history of these measurements has been quite complex, and I try to summarize. I mean, don't take really exactly, this is just to give an idea. But you see that basically in the different continents, starting more or less from the 1996, 1996, started to grow up small networks of sites. And when I did my PhD in 2003, I used the eddy covariance data that were available at that time. There were 15 stations available. And then, but then the technique became more and more accessible. And so there were more and more initiatives, also local, continental, but also single people that started to build up the tower, and often to organize themselves in networks that not always are top-down funded. So it's not really like a satellite where there are money to get this data. It's often the opposite. So the university and the person in the university find a grant. With this grant, they build up a tower, and then they join one of these initiatives that altogether try to organize the network. And so you see that the history has been very complex with different networks showing up and also disappearing, merging, and so on. So it's a very complex system where at the moment we don't know even the exact number of towers that exist. Because we know that, for example, there's been a huge expansion in China, but it's still not clear the number of stations that are there active. But for sure, there should be more than the 1,000 towers. Active in the world. I have to say also that this complexity and the fact that there was this kind of bottom-up initiative make the access to this data and also the long-term stability quite complex. And for this reason, in general, there is a decision to move toward the direction of a long-term ecosystem monitoring network. And ICOS, where I work on, is one of them, but there's also Neon and Cian and so on. So with the idea to have really something that is long-term, standardized, and so moving from a pure research question, let's say bottom-up, to something that is a research network that is measuring data that are available for the others, basically. But that's of course it's improving, stimulating the work on the interoperability, but there is still a lot to do in the interoperability. We worked a lot. For example, at continental level, there was a lot that has been done. For example, in US, there is a Neon, the Neon network. There's a good number of stations, and then there is Ameriflex that is also covering not only US but also all the Americas. And then there is collaboration between these two. So there are the Neon terrestrial side that are registered in Ameriflex, so they are processed with the technique and the same method that Ameriflex is using. And in this way, these two initiatives, they are trying to put together the efforts in order to arrive to something that is more interoperable, of course. And the same is happening, for example, in Europe, where we have a European network that historically is built up, but then we have ICOS that is a more organized and more long-term. And also in this case, there is the same, so there is a merging between these two, not a merging, but a strong collaboration between these two in order to ensure the continental, let's say at least level interoperability and try to improve it. I have to say that there is also something, but that probably would say also I have also something later across continents, because for example, Ameriflex and Europe will be really working a lot to develop common standard routines and common things that then will present a little bit more. So there are already steps in this direction. However, if you look globally, there are a lot of stations, and what they are doing is basically that in general, in the past, what has been done, that periodically they all collaborated together in one global initiative that is Flux. That is really a bottom-up initiative, so people just contributing if they want. But always, and that was the problem until now, always with someone that had to initiate it. So someone had to say, okay, let's do a synthesis. So asking to everybody, can you send the data? And then try to do the harmonization and standardization for all the stations. So a large effort that can be done only just really periodically, every 10 years, where that is very difficult to update. And that's why we working on it, and that's also what I wanted to present here and give as a let's say, try to get also the feedback from the early people is that at the moment we can say that this is the situation. So we have a different networks, so Neon, Ameriflex, and so on. I mean, I just put some example. They all provide, in theory, data to a user that could visit all of them. But of course, what is getting is really something that is really heterogeneous. So for each of these, they have to check the license, check which is the policy, how to cite, and then check how you indicate the temperature, if the units is correct or not, is the same or not, and then translate everything. And that's make our measurement really difficult to access. What is the idea, or what has been the point is that to try to move in something that I called the Fluxnet shuttle. I mean, I didn't put the reference, sorry, but there is a reference in the document. There is an idea, prospective theory by geoscience describing that where the idea is that the single network and the single initiatives could organize themselves I call this continental cluster. In fact, it can be also not a continent, can be a single network, can be also something that is not continental, it's just a matter of organization. However, where everybody agreed that in addition to whatever specific products they want to provide externally, because there are specific situations, specific questions, scientific questions, they could also prepare something that is common. What does it mean common? Process in the same way, using the same tool, following the same standard, using the same data license and the same metadata, so that we can have a machine-to-machine system able to visit all these regional maintained databases and get the last version of everything and build up to basically a collection all the time that this Fluxnet chapter run and is visiting all these Fluxnet version baskets in order to get the last version, assign a DOI, and knowing that there is a common data policy and a common standard so that they are directly usable. That is the overall idea that I had. And okay, I finished my time, and so the last slide is this: is that what has been done until now, and what is needed to be done. So what was achieved until now is that, particularly between Europe and US, we were able to arrive to a common agreement on how to assign an ID to a site so that they are unique, and then we can identify. We define that this was the variables, the unit, which unit to use, and that's also an issue because we know that in US, for example, in Europe, we use different units for the distance and for the weight and so on. Develop a common harmonization tool, common metadata system, and so on. And there are also things ongoing. For example, Neon is investing a lot in producing, and also Flux in producing data in a different format that is more a standard, like HDFI or NetCDF. ICOS is translating the metadata in a DCAT system, for example, through the activities in the entry fair project, and everybody are trying to moving in the direction of the CCBY common data license that simplify for the user. What is missing, however, and here I end, we don't have really a general agreement on the common format that will be important. We are still missing a lot of additional metadata that improve comparability because we have metadata only for one part of the story. We don't have a good plan for the maintenance of this common tool, so we develop it, but must be a collaborative effort. And then we have a problem of the proper recognition of people that contribute with the data, because as I said, it's not a top-down initiative where there is some funding. It's a single people that set up and share the data. And of course, they would like to get the proper recognition from that through the data usage count, but also the importance of the data use count. We need to involve the involvement of not European and not US networks. We are discussing with Flux, with Peter, and so that's will be for sure something that we will done soon. And finally, we will need to develop these technical tools in order to have this Fluxnet shuttle, and so this more regional responsibility, but with a common agreement working. And that's all. I hope that I was able to do this in time.
Thanks, Dario. So now so any questions to Dario? Quick question. Okay. So now we have a 5-minute presentation from a different research infrastructure, starting with Torino. So Ralph will give a presentation management and interoperability of the Torino Flux data. So Ralph, you can take over.
Well, I hope you can hear me. Then I will try to share my screen. Here we are. Okay, so I'm coming from Research Center Juli in Germany, and I'm responsible for the data management coordination of the Torino data infrastructure. And just a few words about that. So Torino is a network consisting of a number of German large research centers. And it's designed as a long-term observation network for hydrological and ecological parameters on different scale. And we're running this system or this infrastructure since about 12, 13 years now. And we have a lot of observation stations, weather radar devices, lysimeters, and so on. And of course, also a number of eddy covariance stations, roughly about 20, where data are collected and shared within at least this network. So Tirino is, from the data management point of view, structured as a distributed data infrastructure, which means that each center has its own database, if you like, and we are communicating with all other institutes using standardized OGC web services, mostly sensor observation services, or now using the Sensor of Things API and then other OGC services. So therefore, we have Tirino is more or less acting as a hub for data, which can be, I will come to that later, where other portals or other infrastructures can access these data using these standards. Okay, of course, as I said, we have data also from eddy covariance stations, and I call it data flux or flux data. I think it's more or less the same as that what you also do. So after data collection, we either upload the data to the host institution, or in some of the stations, which are ICO stations, the raw data are directly uploaded. Then the data will be processed, quality checked, and then there will be a data access, backup, and storage in our institution. And for this, we have developed a time series management system, which is doing all of this automatically, including the storage, into database. And finally, the data automatically published using standardized web service. And also, if you do downloads, the data can be also characterized by a PID or a DOI, which can be issued by us. Okay, so we have, of course, a number of workflow developed over a number of years for data collection, quality assessment, and publication. And all of this is certified by ISO 9001, so which means everything is documented. We created a number of registries in order to make this at least compatible within Tirino, but also outside of Tirino. For example, registries for sites, for methods, also PIDs and DOIs for data, which means so the common ID for data is already realized within Tirino by having it's not only for Tirino, but we're using it for Tirino for a registry for environmental observation sites. We have, of course, workflows for technical inspection of the data and also for validation of the data, also using the methods and the programs which are using for collecting and processing the eddy covariance data. We have a common licensing scheme, mostly CC BY, which are used, and but it's also possible to use own licensing schemes, which will be then transported to the user. Common vocabularies are used, and the most important thing is that we try to exclude the people from the data processing, which means so they can check the data, but basically the publication of the data as soon as they are quality assessed is automatic. So therefore, we have, let's say, more or less, I will call it, let's say, a data hub, which means we have Tirino as a collection of different institutions exchanging the data using standardized services. And then it's very easy not only to create client applications using these different services, as you see here, for example, but also, of course, the data can easily be included in other infrastructures, and then, of course, also shared. And you saw this in the last presentation. You have all these different portals. So more or less, we consider these portals more or less as viewers to the data which are hold in a hub structure or different hub structures and can be, let's say, access different different aspects of the whole observation structure. Okay, that's it from my side. Thanks a lot.
So I think the next presentation we go to Peter Isaac, who talks about the turn ecosystem processes. Peter, over to you.
Thank you, Guru. Just trying to share my screen now and hopefully bringing up the presentation. Can everyone see that presentation? Hello, can people see the presentation?
It works. It's fine. We can see it.
Oh, good. I'm speaking today on the lands of the Wurundjeri people, and I wish to acknowledge them as traditional owners. I'd also like to pay my respects to their elders, past, present, and emerging, and to Aboriginal elders of other communities who may be here today. What are we doing at present? This is about turn ecosystem processes data. So turn ecosystem processes, otherwise known as Flux processing. We started development in 2009. That was only 2 years after the last real data synthesis from Fluxnet. We chose to use a netcdf file format in order to match the input file format for the Australian Land Surface Model cable. At the time, there were no guidelines as to what to do, so basically ourselves as the data provider, we chose the metadata and chose that to document basic features of the data set. The variable naming convention, there was already a Fluxnet variable naming convention. We chose to go our own path because we didn't really know about Fluxnet at that stage, but the naming convention was at least chosen to be consistent. These are topics I'll come back to later on in the presentation. The software gave us standard processing methods that could be applied to all sites. We've got around about 24 active sites, 12 of which are funded by turn ecosystem processes. So at least we had some standardization of processing methods across those sites. The next one is an important point. Site PIs are encouraged to process their own data. Now, this is a really important point that I think has got a lot of ramifications for arriving at a standardized global Flux data set. If you distribute the processing, then you reduce the need for central resources. So one of the big problems with Fluxnet 2015, for example, a huge amount of time had to get put into that by a small number of people to produce the data set. If you can distribute that processing, it can happen more frequently and the workload is spread across a larger number of people. The problem, though, is that when you start to distribute processing, you run into challenges associated with standardization. If you've got a large number of people processing data, you have to find a way of checking that they are all adhering to whatever standard you've agreed to. What about our metadata? At the urging of Guru, and I have to pay my respects to Guru here, he's been very, very useful to us here, very good. We adopted climate and forecasting conventions around about 2013. We are still not compliant. ANU is pressuring us now to become fully compliant with CF conventions, but it's a work in process. Now, this is an important point because once you adopt a convention, you not only have the capital cost of complying the first time around, but you have a maintenance cost that will go on into the future. So compliance is not simply a once-only thing. It's something that you will do into the future. It's a maintenance overhead that you have to carry. We have a few global attributes, one of which is required, which is the conventions. That simply specifies what conventions we're following. There are many recommended conventions that don't come from a controlled vocabulary, but at least the conventions comes from a controlled vocabulary, so you can trace back what we're following. Likewise, in variable attributes, we've got units and standard name and long name. Units is the only required variable attribute. And again, that comes from a controlled vocabulary. Standard underscore name is a very useful one. Recommended, not compulsory, but comes from a controlled vocabulary. A very useful way of identifying variables across different research groups. and long name recommended but not controlled. I'll come back to the point of controlled vocabularies later in this presentation. Our contributions to Fluxnet. Dario has spoken about Fluxnet. I think Deb will speak about that later on. In the last wheel synthesis in 2007, we contributed about 17 site years from 4 sites. By 2015, we'd managed to get that up to 150 site years from 23 sites. And at the same time, we prepared the basic BATM files for each of those sites. That was a requirement of contributing to the 2015 synthesis. We probably wouldn't have done that unless that was a requirement. What that meant for us, though, was that in producing files for Fluxnet, we had to strip out the metadata from the data. So our own approach was to combine metadata and data in netcdf files, and it was a difficult philosophical thing to do, to strip the metadata from the data and produce simple CSV files for Fluxnet. But it was worth it. I'll come to that later on. The transfer of metadata from our own system of netcdf files to the BATM files, which contain essentially the same information, and Deb will speak, I think, about BATM files later on, is labor intensive. It took a long time. And the BATM files that we produced are not easily read or written by a machine. So I think there's a fair amount of work to do there in terms of making sure that metadata can be easily transferred, and perhaps even revising or reviewing the way in which metadata is presented at present. Towards interoperability. In any discussion about this, I think there are 3 parties involved. There's the data users, the data providers, and the data librarians. I think that our meeting today has got a good representation from data providers and data librarians, but I think we lack people from the data user community. We need to talk to the people who use our data and find out what they want from our data, what metadata they want, and they have to be involved in that discussion before we start deciding on larger scale conventions to use. What's the challenge? Most of our citations of data come from Fluxnet 2015. That's about 80% of the citations that we get come from Fluxnet 2015. It's overwhelming. We get about 10% from the Flux thread server and about 10% from other sources of the data. So Fluxnet is the big game in town. There's one Fluxnet, but many regional networks. Fluxnet is a recognized brand, and it's the logical place to start in working out a common way of moving forward in terms of metadata, variable naming conventions, and so on. We have to accept that Fluxnet is the big game in town, and we need to work with them and follow them. There's already happening an initiative to align Fluxnet, Ameriflex, ICOS, and Neon. That represents a large part of the global Flux measuring network. They're already aligning themselves. We need to follow with that. However, there are places where the Fluxnet conventions, the file format, for example, and delivery could be improved. What I would like to propose is a system where regional networks, such as Flux, Southeast Asia, China Flux, and so on, can remain autonomous, but Fluxnet as the global platform is standardized. Then regional networks remain free to do their thing, but Fluxnet can look at redefining its existing conventions with input from the users, the librarians, and the providers, and provide that global standard of data. What needs to be done? I think there are quite a few things that have to happen before we can start converging on this interoperability of global Flux datasets. We need to agree on what are the mandatory variables and what's the naming convention we're going to adopt. We need to progress and we need to agree on the best data processing path. The Fluxnet processing is good because it's very standardized, but it may not be appropriate for all sites. Is there room here for having a site PI contribution for processed data rather than just a default processing using the Fluxnet data path? We need to agree on mandatory metadata. We could use an existing convention, and we've already adopted climate and forecasting metadata, or should we develop a new one? So what convention are we going to use for mandatory metadata? And lastly, we should agree on a file format. I'm a fan of netcdf, possibly HDF5, but something which is self-documenting, works across all platforms, and is web-enabled. There's a fair bit of work to do I think, background work before we get to this global interoperability. Lastly, I wanted to go through a few slides defining some optimizations. In this slide, along the bottom axis, the horizontal axis, is the metadata content. Now, 0 means that I give you no metadata in the file, maybe a single line that gives you the variable headings, but no other information. On the right-hand side of that horizontal axis, at 100%, I give you the analysis pathway, everything you need to write a paper. So that's complete metadata at the right-hand end, 0 metadata at the left-hand end. The time and effort that it's going to take me as the data provider is on the vertical axis. It takes me no time to give you no metadata, but it takes me a large amount of time to give you all the metadata that you need to publish your paper. If we look at it from a data user point of view, it's the opposite way around. If you give me no metadata as a data provider, then myself as a user, I have to spend a huge amount of time to figure out how to use the data and what to do. At the other end of that scale, at 100%, if you give me all of the data I need to do my analysis, even possibly the analysis and how to write the paper itself, then my effort becomes minimal, becomes 0. Now, somewhere in between those two, there is a compromise or an optimal point. And the yellow line in this graph shows the sum of those two. There is an optimal point here where the time taken and the effort taken for a data provider to put the appropriate metadata in the file or accompanying the file, and the amount of time saved by doing that reaches an optimal point. If we go too far one way, the community as a whole loses too much time. If we go too far the other way, same thing happens. We need the data librarians and the RDA community to guide us to where that optimal point is. And lastly, I'll give my acknowledgements to Turn Ecosystem Processes and the Data Services team. Thank you, Guru and Anu, for the chance to present.
Peter, so quickly go next to to Deb. She'll talk about the Flux data standards. So Deb, I will stop and then you can share your screen. Sorry, Deb, we can't hear you.
So I don't see share screen anymore.
It's next to the mic button. So on the left-hand corner, there is a mic, and next to that one, there is a screen button.
Okay, yeah, no, it's, of course, now I'm finally being asked. All right, there we go. Okay, can everybody see that? I'm going to assume yes. All right, so I'm going to talk a little bit about Flux data standards, following on some of Dario's points. And the first point is I just want to introduce you to the Ameriflex Collaboration, which Dario mentioned. That's the one that I'm working within. I lead the data team. So right now we have about 390 sites that contribute data. We have about 550 in the overall network. So we get a lot of downloads. We also host the Fluxnet 2015, which is the most recent version of Fluxnet. We've been hosting Fluxnet since 2007. Now, one thing you'll notice is there's only 212 sites in the Fluxnet 2015. One of the other aspects that hasn't been touched on is that there's different levels of quality control at each of the levels of processing. And there's a lot of final quality control that happens before the processing at the Fluxnet level because there are, this is where we do the gap filling, this is where the partitioning, where we're trying to attribute the fluxes to different processes and things. where a lot of these processes happen, and you only really understand some of the data quality issues when you're trying to then utilize that data in this processing. And also because we moved to CC BY, some sites chose not to join that. So anyway, just wanted to give you a little bit of feel for the kind of numbers we're talking about here. So also, it's been talked about, but I wanted to show the processing pipeline. We have the raw data, as Dario mentioned, is 5, 10, 20 hertz. That gets processed in Ameriflex's case by the site team, same as Turn, and then that comes in as 30-minute averaged data, and the metadata, which we call BATM. Then Neon also contributes their 30-minute data in the same format. The plan that Dario was talking about, this Fluxnet shuttle, is then through the OneFlux processing code, which is now an open source code that we and the ICOS team have worked together, actually, Dario, to build that code, which will in the future, at least as of now, be the Fluxnet processing code. So where are the standardization points? A lot of this already came up. For us, it's that process 30-minute data, it's the metadata, it's also the that OneFlux processing to get to that Fluxnet version of the data, and then also the metadata, which that format we call the BATM interchange format, so the BoF. And so let's talk a little bit about those formats. Back in the mid-2000s, we started standardizing. This did not try to follow the CF conventions, although we did look at them at the time. But with the European team, we worked together to just come up with standards, period, because at that point, up until then, we were actually having to convert from each individual network's naming and units, and that was incredibly time consuming. So I didn't put the link to the site, but if you go to the Ameriflex site, you'll be able to find the links to all the standards that we now use. This is just the top end of the table, showing you that we have tables that then describe exactly what the variable name is, what its description is, and its units, and we've standardized on those across Ameriflex and Europe. So across the Americas as a whole, and across the European network that Dario is part of. So the BATM has been mentioned several times and how complex it is. I wanted to give you a little bit of feel for this. This is for all the non-continuous information about the site, about the vegetation at the site, about disturbances at the site. And so I threw up just one piece of this information. This was just disturbance metadata about an agricultural site, just to give you the feel for the amount of information just for one piece of data we need, because we need the dates, we need characteristics about that measurement. So it's very complex data to represent. So in the interest of time, I brought back up Dario's slide. I had the feeling he probably wouldn't have time to really go through it. Right now, we've got lots of standardization efforts going on across the various Flux networks. I think we do have some standardization between the Americas and Europe. The next step for the overall network is to look at how we standardize across all the networks, and in particular how we move to a common understanding that allows us to have this Fluxnet shuttle that Dario introduced, where we have the ability for each of those regional networks to build a compatible version of the Flux data up to the Fluxnet processing level, and make that available to users where each of the regional networks is creating their component of that. So that's our goal. We're still a fair distance from that, but that's what we're aiming for. And that's where we have a lot of questions about any advice that folks have about how we get there, as well as on the standards and some of the processes for how we can. And we'd also love to talk about citations, since that's always a challenge, though many of you have already heard me on that point. So with that, I want to turn it back to the host, and now I have to figure out how to stop sharing. Did I stop sharing? I think I did.
Thanks, Deb. And now, so we have one more presentation from Sion, South African research infrastructure. Unfortunately, Gregor can't come for the meeting, so you send a slide with a recorded slide. So I'll try to run that. So you can see the slide. Somebody has to tell me, otherwise I can't see anything.
Yes.
Yeah.
We see the slides.
Cool. Okay, so I will run this slide.
Good morning, colleagues. Thank you for inviting us to look at this workshop. I'm going to be talking about Flux data within the South African Environmental Observation Network, SAON, and the associated FTHEON research infrastructure, which is linked to SAON, and is a newly developed research infrastructure that is trying to set up 6 landscape-size research infrastructure sites across South Africa, which will also have Flux as one of the major components. Is a research facility under the auspices of South Africa's research funding organization, the NRF. We operate a distributed network of long-term environmental observation sites, and these are distributed across 4 terrestrial nodes, which cover the major biomes within South Africa, including the fynbos, the arid regions, the grasslands and the savanna regions, and 2 marine systems, the shallow marine systems and the deeper marine systems. Situation in South Africa. There are a couple of things that need to be borne in mind. First of all, we are a very small community. There are only a handful of researchers using this technique within South Africa. Secondly, we are filling a vital global gap. If one looks at the Fluxnet 2015 map that's presented on the left and zoomed in just on the African continent, you can see that there is a massive underrepresentation on the African continent. And for a continent with about nearly 1 billion people, or nearly 1 billion human inhabitants, there are less than 30 long-term flux measurements that have been taken, and most of these are no longer operational. So while SAON's Flux network is still being established, and we are in the process of developing new long-term flux measurement sites, there's also the opportunity to incorporate a few existing datasets, particularly within South Africa. And it would make sense to the community to incorporate these in the same data platform. This gives us the opportunity to build data systems incorporating lessons that have been learned from other networks, because you guys have spent a lot more time and focused energy in getting this right, or at least developing it. So there are a couple of things that we realize are important. First of all, data interoperability is very important. We need to have the data that we are producing available and speaking to data that's being produced in the rest of the world in order to be able to do intercomparisons and have global lessons. And this is particularly important in terms of the massive gap that one is seeing on the continent. Secondly, the data needs to be both timelessly and openly available. And this is something that we're trying to facilitate through SAIL. But we also need to account for the concerns of some of the stakeholders. First of all, the issues of citation that have been brought up so far in this meeting are very important. Researchers who put funding and effort into getting data produced need to be confident that they will get credit for the work that they have done. And secondly, we still are getting requests for data moratoriums from partner datasets in order to hold off the publication of data to a broader, potentially more mobile and agile community to allow for the initial publication of the work by the researchers who are putting this data together. Lithium Flux data is going into a broader data network or data platform operated by SAIL. This is called SAIL Open Data Platform. And this is an infrastructure that is being developed to provide hosting environment with aggregation of earth and environmental data sets and metadata sets. As a result, the Flux data that we're talking about at the moment forms a very small part, or only forms a small part, of a much broader range of data products that the South African that SAIL is hosting. These include a variety of maps and data products for environmental management within South Africa, including things like the South African Risk and Vulnerability Atlas, the Bioenergy Atlas, the Carbon Sinks Atlas, and the Maritime Information System. The data coming in from the research infrastructures, both the terrestrial and the marine infrastructures, which will include a lot of real-time and collated data sets, one of which would be the Flux data under the Ephion research infrastructure, and then also the data that is coming from the terrestrial and marine and coastal nodes. Once again, thank you for the opportunity to participate in this particular workshop. I think it's going to be very useful in framing the thinking that we've got in the development of the data infrastructure that we are going to be using to host the Flux data coming from SAIL. If you have any questions, please contact me, or let's see how it works out in the workshop. Thank you.
Okay, so that was the talk from Gregor, talking about the SAIL infrastructure. So the next part of the conversation, so we go to the group discussion. I'm pretty sure everybody is in a Miro board. The idea is to basically go through, we have set up a few questionnaire. So idea is to answer that question as a group, and then probably come back and then discuss about that. So we are 40 minutes remaining, so we can have 3 minutes per question, and then we go through each of the question, and then we come back, and then probably we'll have about 10 minutes to quickly summarize, and then discuss what next from here, kind of thing. Okay, so if we can start, so everybody has gotten access to Miro board? Yeah. So I think the best thing is probably we go to the Miro board. The first question is the Flux data sharing. So we have put up an instruction. So basically on the left-hand side, there is a sticky note. You can drag and drop and then write up the answer. So it's quite easy. You can just on the left-hand, that menu, all the, whatever the editing tools, everything is there. you can just
Guru,
write up.
sorry to interrupt. We can't see your screen.
Okay, yeah. See the screen now? Can you see the screen?
Yes, thank you.
Okay, cool. Yeah. So the main reason I didn't share the screen is I can't see anything else if I share the screen. Okay, so this is the first question. Let us go on the Flux data sharing. So the question is, and the other thing, on the left-hand corner, so if the zoom, you can increase the zoom if you want, the questionnaire, and then you can move your board like this. So if it's small, you don't have to worry. You can just increase the zoom and then, to a manageable zoom on your screen, depending on which screen you are using. Yeah. So what I'm talking about, this sticky note, you can drag and drop and then write your. And if you want us to, you can put your name as well as part of the sticky note, if you don't mind. Otherwise, it's fine. Okay, so let us start with the first question. So I will start a timer, 3 minutes timer, and then we can go from there. So the main intention is to basically, you're worried about the fair bit of a good presentation from the couple of research infrastructure. So then from a research infrastructure perspective, how can we improve the Flux data sharing between the research infrastructures? Some of the comments from you, from the participants would be great. And the other question we are asking as part of this is, Dario talked about the Fluxnet shuttle. So I just wanted to ask, the Fluxnet shuttle is one of the option as a framework for the data sharing. So you can drag and drop the point if you agree with that to the yes, no, I'm not sure as well. And we have provided a link for the paper Dario and his team has written about the Fluxnet data shuffle. Okay, everybody had enough time to write up something? So can we move to the next question?
I hadn't finished.
Okay.
Yeah, at least people are having problems with the mirror board.
Sorry?
Yeah, I think there are at least 2 people having issues with the mirror board if you look at the chat.
Right, okay, sorry for that. Okay, so your browser doesn't help. So can you try on the Chrome, Anna? And probably, I'm not sure which one, so which browser you're using.
Sorry, I'm using Chrome, but I tried several times to re-enter or refresh the browser, but it doesn't work. It seems to be just loading forever.
I have
But
a suggestion.
maybe if you just share the screen and then we can discuss.
Yeah.
Right, okay.
But Maggie, you can also add your comments in the collaborative notes. So we have created a section by the questions.
Yeah, so
Thanks.
Anna, can you put that again, that link?
Yeah.
In
Yeah,
the chat?
I'll do in the page too. Yeah.
Yeah, thanks for that. Okay, so we go to the next question. So the next one is then how can we incentivize the Flux data sharing between the research infrastructure? So what is the incentives? So start the clock. Okay, so moving on to the next question. So we wanted to know what are the data and metadata standards used in the community. So the fair bit of a thing was in the presentation. So it's a good place to put those things. Yeah, start the times. Okay, going to the next question. So this one is basically, what kind of information the metadata should be included in the shared data. So you can call it as like a minimal or the very critical information that needs to be included. Let's start the time now. Okay, so moving on. So this one is to want to understand what are the control vocabularies that are used in the Flux community. And then, so it has got two questions, this one. So you name the control vocabularies. And then what we want to ask is that what are the common machine readable vocabularies that would improve the research infrastructure? And we have provided few options. And then what needs to be developed, as a priority kind of a thing. So just to understand some of the priorities. So in the first one, so the control vocabularies that are used, it can be like a local, and then if there are any machine readable, and then so some of the things we have identified and what should be the priority in the development. So time starts now. Okay, so moving on to the next question. So this one is about I assume that we work together. So what are the forum we should be working on? So this one is to the next aspect. What is the preference in the community? Start the time. So probably this one doesn't take much time. Probably 2 minutes or 5. Okay, so the next one is there are other communities who have gone through this. So is there anything we can learn from the other communities? So if there's any examples, you could keep off. So probably I'll just provide like a minute for this, such an interest of time. Okay, so that is some of the questions. So we have 8 minutes left, to be precise. So what we can do is we can just quickly go through some of the answers. I think Anu was doing a bit of a clustering. Okay, so the first one, the research infrastructure, how can we improve data sharing? So Dario has mentioned that the Fluxnet, I think there is looks like there is a general consensus that there is one more Fluxnet under the Fluxnet banner, but it requires a fair bit of work under the Fluxnet banner. So one of the things I just wanted to tease out is that in the Fluxnet, it's more on the central integration. So basically, everybody provides the data to the Fluxnet. Is that still what the community wants, or, for example, is that will there not be any data sharing between the other infra, for example, from Turn to ICOS and Turn to Ameriflex? So everything has to go via the Fluxnet. Is that the still the community wants? So Dario or Deb,
Yeah,
anybody?
I can say that. I really agree with what Peter said on the data users. I agree with a lot on data users in all the decisions that we take. What they want, they don't need a single web page. They need to get the data, and they need to get the data in the standard format with a common license that is easy to understand and apply. And that's why the Fluxnet chapter, in my opinion, was an option. Because in this way, we don't need to, because maintaining a Fluxnet place where the data has to be transferred from one place to another, it's however a cost, and it's something that is not needed. Why you have to move the data around? I mean, you can get the data nowadays that are stored and maintained, and the data accumulation is happening in different places. Just a common tool that is accessible. So I don't think that the future is another Fluxnet data set like in the past. I really think that the future is more on this idea of a distributed repository. And the point is that, for example, we had the case for the Australian site. That since we do the synthesis sticking to our climate, we go for 1st of January, the 1st of December. So we always cut in half the growing season of the Australian sites. While with a system like this shuttle, then 6 months later, the data from Australia can be added with a full growing season, and then 6 months later again, the North Hemisphere will contribute, and this will be a live system. So I don't think that the user wants to have a Fluxnet portal. They want to get the data easily and updated with a common license and standardized.
Cool. Thanks, Dario. And for the other question, I think there's overwhelming support for the use of Fluxnet shuttle as a valid option. That is very good, very nice. And then for the incentives for the sharing, I think there is a bit of a citation is one of the driver that was explicitly mentioned by Peter as well.
Sorry, Guru, this is Peter here. Can I just come in with a comment?
Yeah.
I commend Dario on his biogeosciences paper that put forward the idea of the Fluxnet shuttle. I think it is the only way that this that provision of a global Flux database can be sustainable into the future. I do think that we need to look at what options are available to Fluxnet off the shelf. So rather than going down the pathway of developing a Fluxnet specific technology and software stack to implement that shuttle, we need to have a look at what's available off the shelf and use whatever can fit the functionality or provide the functionality that's needed there.
Yeah. I agree with you, Peter.
That's a great point. And it's in part what I asked, for example, in the context of this that Europe is connecting all the research infrastructure, but it's also what this RDA community can really help on. So whatever is already existing without reinventing anything. I don't think that the idea to have a common way, a single way, let's say, to access data that are stored in different places, but they share a common metadata scheme, so that you can find them and download like if they were in the same server or location. Is something so new. I mean, there must be something already existing. It would be great for the RDA community to get suggestion of what we can just take, copy and paste, let's say. That would be very important.
Yeah. So Dario, then there need a consensus for every aspect of the interoperability from structure, because for example, the turn structure is different from the Fluxnet, and then the vocabularies needs to be standardized. There's a fair bit of a work. I think it's a good to plan that, I guess, which was rightly mentioned in your slide and that slide as well. Okay, so we have 1 minute left. So what we will do is probably we will synthesize this and then.
Sorry, just very shortly on the that is really general. I mean, the idea of, the overall idea is that the peculiarities are very important, and so it's very important that every single network is able to do the processing or to do the metadata in the way that they want and they think is best for their specific situation. The point is to add on top of this also a common layer where we all do everything the same way, so that that everybody are able to do the metadata and produce the file in the way that their specific communities are requesting, but at the same time we also add this layer of interoperability. Okay, that must be the, in my opinion, one point to take in mind. Nobody is asking to convert everything in the standard. It's only to add on top of what we routinely do the version that is the standard, that is the one accessible by the shuttle.
Yeah. So do you think that that will be more like a crosswork, the translation? So that will be some of the work that the research infrastructure can work on.
Yes, yes, that's exactly. I mean, it's a kind of translation. So it's an agreement of the common scheme and common basic set of that in order to start on, and then everybody has to build up their system to translate whatever they do in the common standard. If they are not already using the common standard as a default, let's say, but this is something that is, in my opinion, feasible. I mean, we in our experience is feasible. Let's say we already did this partially, and it's clear that if you do this all together, it's much easier.
Yeah. So we are already 1 minute over our time. So we will synthesize all this and then send it to everybody who have put their name in the Google Doc. The other thing, what we wanted to quickly make a bit of a, at least decision is that, what form we should use to discuss further. There's a few things needs to be discussed, and then I'm pretty sure that everybody has got a fair bit of an interest in this one. Should we form like an RDA interest group, or we discuss internally first, and after that we make a decision? So what is the approach we should take? Okay, looks like people are still speculating. So we can discuss this offline, probably via email, or offline another meeting if possible. So people, we're happy to send an invitation to whoever attend this, and then people, opportunity to contribute. So if people are happy, if we just set up another meeting to, once we synthesize that, we send this as a document, and then set up a meeting to discuss further, where to from next. So we don't want to just leave this, just okay, finish, and after that we just go away kind of thing. So is that okay?
Yes. Can I just a really small short note? I mean, I think that it's very important to meet again and do this group and discuss. But as I also put in the system, we need to do some practical step. I mean, this is something that is discussed since a long time, probably too long. We have everything ready to make a first demonstration, because already two very large networks that together makes 800 sites already developed something. Now it's not perfect. We can change and discuss, but we need to do a demonstrator, in my opinion, if we want really to get the feedback of the users. Otherwise, we will continue to chat and never do a step.
Yeah, no, I absolutely agree with you, Dario. So that's why probably in a couple of meetings would be quite helpful. So what are the low-hanging fruits? Just to identify what are the low-hanging fruits, what we can do quickly to demonstrate some of the interoperability work. We can even set up like a test bed as a small test bed work, and then focus on that one. So if everybody is happy, so we will send a doodle poll to work out a next meeting kind of a thing once we synthesize and send around. Is that okay? Everybody, so you can send a thumbs up or whatever anything. Okay, that's cool. Okay, I really apologize. We are 5 minutes over. I'm pretty sure Europeans are really keen to go for their lunch, and then we in Australians are very keen to go to bed, and Americans probably for a breakfast. Thanks, everybody. I really appreciate everybody's presentation, and then a round of applause for all the presenters. Like such a fascinating presentations. Thank Dario, Peter, Deb, Ralph, and Gregory, in that sense. Really appreciate it. And then Anu and I will basically synthesize the information and send around as an email to all the participants. And then we will set up another meeting to discuss further and where to from next. Sort of thing. Thank you all. Have a nice rest of RDA, everybody.
Bye-bye, everybody. Thank you.
Thank you.
Bye.
Bye-bye.